this is a double bonds, adding HBr, proton's going to be added first, right? That proton go to the less substituted side, so we get the more substituted carbon giving a positive charge. Then the bromine will capture the carbocation. So bromine is nucleophile, sitting on the more substituted side. We've been talking about that amount of nickel product so many times. Usually, you know these things. HBr can be added by another way, which is a radical condition. Adding hydrogen peroxide or any other peroxide, if you heat it up, oxygen breaks, make the oxygen radical that take the hydrogen from the HBr, so you actually forming the bromine radical there. Bromine radical is electrically efficient, so the pi bonds gets the bromine first, not the hydrogen first. So you get the bromine added on the less substituted side. More substituted side, you get the radical, which captures the hydrogen in the second propagation steps. Then you get the bromine added in the different positions. And that's an anti-molecular products. So this is what we have talked about in chapter 8. The triple bond thing, pi bonds of the triple bond, get the proton, you get the hydrogen goes to less substituted side, more substituted carbon being a cation, but this is the double bond cation, so before binding cation, which still can be captured by the halogens. So you get the one addition of HBr and producing the Markov nickel products. This can be done again because the products still have a pi bond, so it doesn't need to be same electrophile. Actually, we don't talk about the question that we can actually mix things together. But let's say it can be done one more time because a pi bond has a triple bond has two pi bonds. So it can happen twice. So by adding another one, proton will go to same less substituted side. Yeah. And then the bromine will be added that position again, then we get the two bromine on the more substituted side. But both of them are Markov nickel products. And then the HBr in the hydrogen peroxide makes a bromine radical the same way. Bromine is going to be added first on the less substituted side, more substituted carbon being a radical that capture the hydrogen. Then you're going to get the bromine on the less substituted side. These are anti-Markov nickel products. Again, this can repeat because they still have a pi bond. So if this repeats, then the bromine still goes to less substituted side because it's a radical conditions. And then that is a hydrogen in the end. So this is kind of a boring now because it's a repeating. But once you understand these concepts, you can apply it to the others. It's pretty simple. And these ones are easy one to get. Adding halogens, yeah, sure. This is another easy one. I mean, this one double bond because of variation there, because you can have a halogen in the non-nucleophile solvent, like then you can add the halogen on the nucleophile solvent, like the water or alcohol, things like that. So there's some situation may differ, but if you're adding a halogen non-nucleophile solvents, bromine is going to make a brominium ion, right? Breach ion. Then the kicked out bromine will come back and attack from the backside. But when it attacks from the backside, it's going to go and make an attack on the more substituted carbon, because the more substituted carbon will have a more electrically efficient carbon, more carbon cation. So that way, the dibromide is a trans because it's an anti-emission. Triple bond, we are expecting similar things. It's not exactly a breach ion because the geometry doesn't really work well because it's double bonds. But anyway, let's just assume that it goes the same way. You get the bromine ion there. Kicked out bromide will come back, they're going to attack on the more substituted side. You're probably going to get like this. And trans is a problem most likely you get, but this can also happen. But this can go to another one because you still have a double bond. So if you don't add just 1-to-1 ratio, if you add more than one, like 2-to-1, then you can repeat this thing one more time, and you can all fully add the halogen in the end. So this is basically the very same reaction that we discussed above, just repeating twice.